Welcome back. We saw the length of arc length formula in the last video of concept 8.1 part A of the videos. Now we are going to see some examples based on these two formulas. And then there are a bunch of videos for the additional suggested problems, which you can find them in section videos as well. So you have there are about 4 problems to refer to for to learn the various forms of this arc length. So let's do the first example. Find the length of the arc of the semi-cubical parabola y square equal to x cube. The curve is important between the points 1, 1 through 4, 8. We are given this figure y square equal to x cube. Here the question is whether we want to isolate the y or we want to isolate the x. It doesn't matter which one you want to isolate. We will try to isolate y. If we isolate the y, then and then you have to look for the bounds for x. And then if the bounds for x are given, then you will go with 2, formula 2. Then if you are able to isolate x, then and if you can find the bounds for y, if you can find the bounds for y in the problem, then you can go with formula 4. So let's try to isolate y in this one. So y square equal to x cube. So y is square root of x cube. Another way of writing is x to the power 3 by 2. Now what are the bounds for x? Bounds for x are given here. It is from 1, 1 to 4, 8. In fact, we have both bounds. Both x bounds are there, y bounds are there. So we can choose whatever is appropriate for the problem. Now we will choose the x bounds because we have isolated y. So x bounds is 1 through 4. So how do I get those? So this is the x coordinate and this is the x coordinate. The arc lies between the x value 1 to 4 like that. Then what is step 2? So once you do that, you have to figure out which formula you're going to use. Length of the arc is square root of 1 plus dy by dx the whole square dx, because we know the bounds for x, which is 1 to 4. So this formula may be appropriate for this problem. In case you had isolated x, then you have to look for the bounds for y, which is also there in the problem, which is 1 and 8. Now, so we have to work on the integrand here. So let's start finding the derivative. So that is step 3. Now we're going to find out the integrand. So y is given to be x to the power 3 by 2. So y prime or dy by dx is derivative. This is 3 halves x to the power 3 halves minus 1. So which is 3 halves x to the power 1 half. So dy by dx, the whole square, the square of this, which is 9 by 4 x. So I'm squaring this. I'm squaring this value, which is 9 by 4 x. Then 1 plus, the integrand is 1 plus dy by dx, the whole square. That is 1 plus 9 by 4 x. You can either keep the expression as is, or you can also try to simplify this. It doesn't matter in the problem. So we have got 1 plus 9 by 4x for the expression inside the radical. So let's evaluate the integral now. So it is L equal to integral 1 through 4 square root of, this is the step I'm looking at. So I'm going to substitute 1 plus dy by dx the whole square, which is 1 plus 9 over 4 x dx. So here I can use substitution method to do this problem. So let's apply u sub method. So u equal to usually the expression within the radical. What is du? Is 9 by 4 dx. Whenever you introduce a new variable, you have to also change the limits. The original variable was x. The new variable is u, which is 1 plus 9 by 4x. The lower limit is 1. So if you substitute 1 to x, we get 1 plus 9 by 4, which is 13 over 4. The upper limit is 4. So 1 plus 9 by 4 times 4, which is equal to 10. So the new limits for u are 13 over 4 and 10. So now if you go back to the step and replace all all of them to the new variable, so it is u equal to 13 over 4 through 10, square root of u, and then dx from here, let's isolate dx, then you'll have to multiply this by 4 over 9. 4 over 9, 4 over 9. So these two get cancelled out. So dx would be equal to 4 over 9 du. That is our dx. 4 over 9 is after all a constant which can be pulled out of the integral sign. Integral 13 over 4 through 10 square root of u du. So it is 4 over 9 u to the power 1 half. So it is u to the power 3 halves over 3 halves between the limits 13 over 4 through 10. So it is 4 over 9 times 2 over 3, then u to the power 3 halves, which is 13 over 4 to the power 3 halves minus 10. So the first upper limit, so we are going to substitute the upper limit for the first one. So it is going to be 10 to the power 3 halves minus 13 over 4 to the power 3 halves. So it will be 8 over 27. Then it is 10 square root of 10. So 10 to the power 3 by 2 can be written as 10 to the power 1, 10 to the power 1 half. So it is 10 square root of 10. You will be using this idea quite often. So anytime you have to the power 3 halves, you can write x square root of x type minus 13 square root of 13 divided by 2 to the power 3 halves, 4 to the power 3 halves, which is equal to 8. 4 to the power 3 halves is 8. So now it's only a question of simplifying this. It's 8 over 27 times 80 square root of 10 minus 13 square root of 13 divided by 8. So these two 8s cancel out. So the answer for the length is going to be 1 over 27 times 80 square root of 10 minus 13 square root of 13. In these problems, avoid writing the answer in decimal form. You have to leave them exact. Exact means leaving it with the radical expression. If you get a radical form, then a root of 13, you don't have to find out the decimal equivalent of root of 13. But if you have a root of 9, you would write that as 3, but root of 13 can be left as root of 13. So this is leaving the answer in exact form. Now let's try another one. Set up an integral for the length of arc of the hyperbola xy equal to 1 from 1, 1 and 2 comma 1 half. So let's actually solve for y, xy equal to 1. So step 1, is to recognize y as a function of x or x as a function of y. So you're given xy equal to 1. So we will isolate y. You can also isolate x, y equal to 1 over x. Sometimes the problem can be difficult if you do the other way around. So once you get to that step, and if the integral becomes very hard, then you may want to switch your role of x and y. So xy equal to 1, then you're isolating y, so which is equal to 1 over x. So we have to look for the bounds of x in this case. The bounds of x the limits of x are 1 and 2. So how do we get that? It goes from x equal to 1 to x equal to 2. So those are the bounds of x. So now step 3, recognizing the formula. The formula that we are going to use for arc length here is L equal to integral 1 through 2, x equal to 1 to 2, square root of 1 plus dy by dx, the whole square dx. So y is 1 over x, dy by dx equal to derivative of 1 over x, or x to the negative 1. So you can write 1 over x as x to the negative 1. So it is negative 1 x to the negative 2, or negative 1 over x squared. So 1 plus dy by dx, the whole square, which is what we need inside the radical. It's 1 plus negative 1 over x squared, the whole square. It's 1 plus 1 over x to the power 4. So the integral becomes L equal to integral 1 through 2, square root of 1 plus 1 over x to the power 4 dx. We are not asked to evaluate this integral. We are only asked to set up an integral for this one. So if you just simplify this, it becomes x to the power 4 plus 1 within the radical x to the power 4 dx. Then we can write this as integral 1 to 2, square root of x to the power 4 plus 1 divided by square root of x to the power 4, which is x squared dx. So that is the expression for the integral. It only says that it set up an integral. So setup of the integral setup is this. Then, as I said earlier, for the additional suggested problems, problem number 12 and problem number 15, these are all done. These are all different types. So here you notice that x is isolated and you are given the bounds of y. So this is one where you would use this formula, the second one. So you will be using this formula here. So you get two types to refer to. So please take a look at the video section, videos of this section. So I have done these two problems in the section videos. Please, for additional problems, you will get an idea. And there are some of them are homework questions as well. So it will be useful to refer to those videos along with the ones that we did. This part of the video is part B, and then part A is also there, which we covered, where we derived the length of arc length formula. Hope these videos are helpful.